Okay, good day again. Okay, so our last topic was about estimating population mean, sample size for estimating mean. Okay, so our topic now will be it is the same, but the topic this is has the same concept, but the topic now is more in proportion or in percentage. Okay, how do you estimate the percentage? Okay, so we have the same formatting here. I just remove from the previous example, we just remove um, the sample standard deviation. We no longer need that, the confidence interval, sample size. Okay, so what we need is just 1.96, the confidence level. Anyway, you can use this other confidence level here available here. I just include it in here for reference. Okay, so since majority of a lot of experiments are done on 95% level, then most likely we'll use that in here. Okay, so we wanted to sample out, for example, 35% of people. Okay, you say, let's say, we wanted to estimate that, um, say, um, we wanted to find a sample, okay, an accurate sample that says that a very minimal range of proportion. Okay, let's say that 35% of people loves your lemonade. Okay, 35% loves your lemonade. Okay, just have to include it here. Okay, so 35% loves your lemonade, then um, 1 minus p, 1 minus of that, okay, 65% of that people who you sampled doesn't love your lemonade. Okay, so you wanted to be very exact, okay, of your experiment. So you wanted to know what is the ideal sample size, okay, for you to arrive at, um, let's say the mean doesn't have a range of too far, like cover this one the percentage. Okay, so this you wanted to achieve this kind of accuracy. Okay, so you will no longer have to worry about um, the reliability of the data that you will be collecting. Okay, okay. So you wanted a 3%. There's a 3% range, so you have an exact in mind of the percentage of people that loves your lemonade. Only that kind of range. We wanted like that. So how many target sample size will I collect if I wanted to achieve this kind of accuracy here? Just a range of 3%. Okay, so we will try to experiment later. Okay, based on the desired confidence interval of proportion that you wanted to desire and how many population you would like to collect. Okay, I mean sample size you want to collect. Okay, so let's start. Let's go straight ahead of the computation. Okay, and by the way, I included here this computation formula here for me not to get lost also, and I will be explaining that later. Okay, and how it works. Okay, so let's go straight. We wanted to test. Um, we wanted to check the target sample size. Okay, so this is um, the confidence interval. I mean the confidence level. Okay, raised to the second power. Okay, raised to the second power, and then multiplied by the proportion, okay, and the q. Q is equals to 1 minus p, okay, over the SE. SE here is the confidence level, confidence interval of proportion, okay, and then we raise that to the second power, okay, there. So you will be collecting 3,884.28, okay, so or 3,885 because there are no half people, okay, you need to um, be exact on that, okay, you cannot express people, okay, by decimals, okay, so you will convert that to 3,885. So you need that example, that sample size for you to arrive of only this for this accuracy. Okay. So Um, let's check if our computations are right. Okay. Um, alpha and square root of PQ, again this one, and then 1 minus this one again over this one. I mean this one. Okay. Oops. I think we messed something. Alright, okay. So see, we arrive, by checking our computations, we arrive in here, 1.5%. Okay, that's the confidence interval of P. Okay, so you will say to me, it's too many, you know. Uh, I need to collect a lot of samples of 3,885. It's a little bit costly. Okay, so you can change this one to 12%. Okay. Okay. So on 12% interval, you can see it changes here to the range of 4. Okay. 33% to 37%. Okay. That's your estimate. You need to collect 2004. Okay. So you will still say to me that it's too costly again to sample a lot of people of 2000. It's a little bit costly. So you will decrease your desired level of confidence. Okay, okay, so 3%, it's 971, 4%, 546, 5%, 349. Okay, most likely you will, I think most of the studies uh, conducted mostly have this sample size of here, 350. Okay, you can convert this one as 350. Or you wanted to have a cheaper sample size, okay, because it's still too costly to sample 350, then you can just add 6%, okay, it's 242 and so on, okay, for example 10%, okay, you just need to collect 88 people, but the accuracy here, you will not be able to predict the accuracy of your confidence level, okay, so that's how it works, okay. So you need desired confidence interval of 10%, from the proportion. You just need 88 people for your study. For just 5%, you need 350. Okay? So I hope that's clear. Okay, so I will explain again this computation here. This one, I've been explaining this for the past videos, and I just put it in here for reference. Okay. It's easy to understand. 95% confidence. I use here the 95% confidence level. So I use 1.96 here. Okay. So this computation here, okay. Um, Here I use that in here. Okay. So target sample size. Okay. So z alpha divided by 2 of raised to the second power. This is the one. Okay. It's d5 raised to the second power. And PQ here is 35% and 1 minus 35%. Okay, that's the Q. P is 35% and then Q is 1 minus 35%. Okay, and is E here and raised to the second power is this one, 5%. Okay, and then voila, this is the answer from the, okay, you need 350 from for 5% confidence interval. Okay, and for this one, I will explain again. Z alpha again is this one. PQ is 35% for P and Q is 1 minus 35%. This is the Q, by the way. 1 minus 35% minus 35%. Okay, that's 65% is the Q. Okay, and N is this one. Okay, and the answer is this one. Okay, so it's more like an algebra. Okay, to get that. Okay, I hope that's clear. You can comment on my video if you want, if you have questions. Okay. Again, thank you for watching this video, and I hope you will subscribe to my channel for more videos.